Alan, Meraz.
So we do some nomenclatures of parent chain and suffix.
We were studying aldehydes and ketones, right?
Yes, sir. And we were talking about some parent chain and combining the suffix.
Just wait a minute. I forgot to name your this in the note. One note. So actually, there is a problem. So basically, we covered this preparation of ketone, right?
Yes,
We
sir.
are done with the preparation. Wait a minute. Okay. Today we are going to start the chemical properties, which is very easy and very important. Chemical reaction. Chemical reactions. Write the topic chemical reactions. So here we are going to discuss about the chemical properties of aldehydes as well as ketone. So the first chemical reactions, a chemical reaction is nucleophilic addition reaction. Nucleophilic addition reaction. So there will be nucleophile and it will be adding in the reactant. How it will take place? It's very easy to understand. As you can see that this is carbonyl compound. This is carbonyl compound. Do you know what is carbonyl compound? If you don't know, please let me know. Alan, Anushka, and Meraz and Amal.
No, sir.
Do you know what is carbonyl compound? Uh, Anushka, your voice is so low that I'm not able to hear it. Okay. So here, first of all, I'm going to talk about this carbonyl compound. And carbonyl compound is the functional group in which C double bond O is present. Wherever the C double bond O is present in any functional group, that functional group is also known as carbonyl compound. So you can see this C double bond OH, this aldehyde is carbonyl compound. C double bond O R and R dash, this ketone is also carbonyl compound. C double bond OOH, this carboxylic acid is also carbonyl compound. C double bond OOR and R dash, this ester is also carbonyl compound. C double bond OX, this acyl halide is also carbonyl compound. So basically, in any functional group, if C double bond O is present, that is known as carbonyl compound. And this chapter is also known as carbonyl compound instead of aldehyde, ketones, and carboxylic acid. So we are going to study about the chemical reaction of carbonyl compound, and here specifically we will talk about ketone as well as aldehyde. Ketone as well as aldehyde. So the first reaction comes out to be this nucleophilic addition reaction. So see how we are going to add a nucleophile to this carbonyl compound. First of all, this oxygen is the second most electronegative element in the periodic table. That means the oxygen is very, very electronegative. Can anyone tell me what is electronegativity? Can anyone define or explain what is electronegativity?
So the capability of atoms to make bonds with others.
That is basically not electronegativity. Basically, what we call it bonds. Every atom wants to make bond in order to stabilize itself. So basically, here the electronegativity is the tendency of any element. Tendency of any element of withdrawing, or we can say, or attracting bonded electron. Bonded electron. Bonded electron. If there is a bond in any molecule like this, covalent bond, you can see This fluorine is highly electronegative. That means hydrogen electron will be attracted or slightly displaced towards fluorine element. So it will have delta negative, this will have delta positive. So basically this electronegativity is the capability, you can say, or tendency of any element to attract or withdraw electron, only bonded electron. Okay, so what it will do, oxygen will take electron or withdraw electron from carbon. Since oxygen will withdraw electron from carbon, it will have delta negative, it is more electronegative, this is delta positive, less electronegative, and the nucleophile is waiting for oxygen to withdraw electron from carbon. Now what will happen here? This is the first step and it is basically slow step. The step 1 is the slow. Now see what will happen. Basically when oxygen will take electron from carbon, it will have negative charge, and then you can see this will be A and this will be your. Since oxygen taken electron from carbon, carbon will have positive charge, and this nucleophile will attack on carbon to satisfy the carbon in this way. So this is the first step, and then comes the second step, which is fast. The step 2 is fast step, and in this you are going to react this with H plus, and you can see there is a negative, there is positive, so it will attack here, and you will get a compound like this. So this is basically your nucleophilic addition reaction. Addition is there of what? Basically nucleophile is adding to this compound. So this is nucleophilic addition reaction. Is that clear?
Yes, sir, clear.
Okay. Can anyone tell me what is the hybridization of this carbon?
So sp2.
SP. Can anyone tell me what will be the geometry of this? If it is sp2, that means trigonal plane. So basically, this compound is plane, trigonal plane. But if you are going to calculate the hybridization of this, it will be sp3 and it is tetrahedral, so it's not anymore planar. And the tetrahedral exists 3D, not in a plane. Please do write. I'm having headache, so I will be a little slow. Sorry for that. Please do let me know when you are done. Let me know when you're done with this.
Sir, done.
Very good. Alan,
Yes, sir. I'm done as well.
thank you.
Done, sir.
Now that you're done with this, very good. Mirage. So there is a question, that is, which one is more reactive towards nucleophilic addition reaction, aldehydes or ketones? What do you think? Which one is more reactive towards nucleophilic addition reaction, aldehydes or ketones? Any one of you?
Sir, aldehyde.
Why aldehyde is more reactive? Is there any reason?
Sir, I'm not sure of the reason.
Alan?
So due to the intermolecular hydrogen bonding.
Oh, it's not like that. Let's take an example and we will see. This is your C double bond OH and there will be an alkyl group. And this will be your R group, or this is. Just take an example of the lowest aldehyde, that will be basically like this. And the basically a smallest aldehyde, not the smallest aldehyde, as you can see, this is ethanol. And the smallest ketone I am going to take, the smallest ketone. The smallest ketone. And I'm gonna make it comparable. Like in ketone, you can see there are 3 carbons, so I'm going to take 3 carbons in aldehyde also. And Anushka, your answer is correct. So if there is a nucleophile, as you can see, both are carbonyl compound, and the oxygen is more electronegative. So oxygen will take electron from carbon. Oxygen will take electron from carbon. There will be negative charge, and there will be negative charge too. So can anyone tell me in which of these two nucleophiles can easily attack on carbon? In which one of the two? So you can see that there is only hydrogen that will repel this nucleophile. Why hydrogen will repel? Because hydrogen has an electron and nucleophile has also an electron. So they will be repelling each other. But at the same time, you can see this whole CH3 group, which has a lot more than more electron than this hydrogen, will be repelling this nucleophile. And in this way, aldehyde is more reactive, and you can say that this nucleophile can attack on aldehydes more easily as compared to this ketone, because there is steric hindrance, more steric hindrance in this ketone as compared to this aldehyde. So this is the reason why it is more reactive, and I'm going to write a point about it. Aldehydes are more reactive than ketone. carbox, two alkyl reduce the electrophilicity of the carbonic carbon. I will also explain the other reason for this, which is very easy to understand. Please do let me know when you are done.
Yes, sir.
Alan, Mark, Miraj,
Yes, sir.
That's
thank you. Okay. Now, see, we are going to take some example of this nucleophilic addition reaction. So, I'm going to take a topic. Some important nucleophilic addition and also nucleophilic addition elimination. ADD, and that is stand for addition, and this is your elimination, and this is your addition elimination reaction. So first I'm gonna take this addition of hydrogen cell. Addition of hydrogen cyanide. HCl. So how we are gonna do this reaction? It's very important. First, I'm going to explain the mechanism, and then I will write some point about it. First, this HCl is not that much reactive, so I'm going to make it a reactive by reacting this with a base. What I just told you, what I just said is that this HCl is not that much reactive. So in order to make it reactive, I just reacted it with a base, and it will form Cn minus. Cn minus and H2O will be eliminated. Now this Cn minus is more HCN, and see there is a carbonyl compound. It can either be aldehyde or ketone, and there is Cn minus. That is basically there is carbon double bond. Carbon has lone pair. Carbon has lone pair. Now see what will happen. How, or can anyone tell me how this carbon has a lone pair now? Can anyone tell me why carbon has lone pair? See how the reaction took place here. As you know that carbon has 4 electrons in its outermost shell. Since carbon is more electronegative, so it will take electrons from hydrogen, and that's why it has this lone pair. Is that clear? And since carbon took electron from hydrogen, that's why it's negative charge. Now see how the reaction will take place. It's very easy to understand. This oxygen is more electronegative, so it will take electron from carbon, and carbon will now have the efficiency of electron, and this electron rich species which is nucleophile, so it will attack on carbon. Now there will be an adduct or intermediate form. Now this two bond over there, and then Cn will be here, and again this will be reacting with H plus in the presence of acid, so it will go to the negative charge because it has positive charge. So positive negative will be attracted towards each other. So see, this will be Cn and this will be OH. And again, this compound is known as cyanohydrate. Cyanohydrate. And this is your tetrahedral intermediate. Tetrahedral is just the geometry, and this is tetrahedral intermediate. Please do write it. I'm waiting. Please do let me know.
Yes, sir. That.
Done everyone? Aaron?
Done, sir.
Yes, sir.
Okay. Okay, so I'm just going to write a sentence about this reaction is that since we are talking only about aldehydes and ketones here, so I'm gonna write aldehydes and ketones react with hydrogen cyanide to produce cyanohydride. Also, we can write this reaction occurs very slowly in the presence of pure HCl. With pure HCl, it's very slowly. Therefore, it catalyzed with the base. With the base and generated cyanide ion, which is a stronger nucleophile, which is a stronger nucleophile, and readily adds up to carbonyl compound to give corresponding cyanohydride. So if there will be a question why we don't use pure HCl, because pure HCl is not that much strong nucleophile, and due to this the reaction occurs very slowly. That's why we catalyzed with base and forms cyanide ion, which is being a stronger nucleophile to give you the corresponding cyanohydride faster.
Sir. That.
Very good. Everyone done with this? Please do let me know.
Sir,
Samad,
can you just explain what is cyanide ion?
due to cyanide ion, which is a stronger nucleophile. Are you talking about this?
No, only just what was cyanide? What was the meaning?
Uh, are you talking about this cyanide ion?
Yes.
This cyanide ion is basically this. We are talking about this. See,
Okay.
this HCN is not that much a strong nucleophile. That's why the reaction occurs very slowly. So we just did we just did catalysis of this cyanide ion, and we basically hydrogen cyanide. Then we will get cyanide ion, which is a strong nucleophile. Okay, H2 is there, not OH minus. Is that clear?
Okay. Yes, sir.
Thank you. The next reaction is basically addition of sodium hydrogen sulfide. Sodium hydrogen sulfide. So again, we are studying the chemical reaction of aldehyde and ketones. So this is your sodium hydrogen sulfide, which is very easy to understand what will happen here. This will come here, there will be negative charge, there will be positive charge, and you know that there will be positive charge and there will be negative charge. So what will happen? See, like this, and then O negative will have this, O negative will have this N plus, Na plus, and this, then you can see another carbon will be bonded with SO3H, or in some books it will be written as OSO2H, both are same, and then ONA. And after getting this, you can do the proton transfer. Do you know what is proton transfer? It's very easy to understand.